And welcome to our webinar in partnership with Delta ML, Machine Learning 101, How to Amplify Your Business with Artificial Intelligence. My name is Matt Schellenberger, ECA Director of Corporate Development, and it's a pleasure to be your MC this morning. Over the last several months, like all of you, the ECA has been hard at work adjusting to this new, ever-changing COVID reality. Physical distancing measures have had a major effect on how we deliver education and networking program to our members. This webinar is one of many education-focused events we will be delivering virtually this fall. We hope that you find the event engaging. Today, we are pleased to have over 60 members and industry stakeholders in attendance, all from the comfort of your homes or your offices. Some housekeeping notes before we begin. Please note that for the duration of the session, you will be muted with your video turned off. Should you wish to interact during the session, we ask that you use the chat function at the bottom of your Zoom window. There, you can write comments and interact with your fellow attendees. Should you wish to ask questions during the event, we ask that you use the Q&A function found on the bottom right of the Zoom window. I will make every effort to ask as many questions as possible during the program. Now, I'd like to introduce our two presenters for the day. First, I'm pleased to introduce Corey Jensen. Corey is the founder and CEO of Alta ML. Previously, Corey was co-founder of Investopia.com, a financial education site that provides content and tools to help educate individual investors. Corey is active in the Alberta entrepreneurial community as a member of A100, the venture mentoring service program at the University of Alberta, and as an associate for Creative Destruction Labs. He also sits on the board of Edmonton Global, the economic development corporation for the Edmonton municipal region. Corey, thanks for being here.
Thanks for having me.
Next, I'm pleased to introduce Alyssa Lefebvre, Senior Manager, Business Development at Alta ML. With over 10 years of experience in business and partnership development, Alyssa is passionate about connecting people and organizations with nascent and disruptive technologies that elevate human potential. In her spare time, Alyssa sits on the board for Global Women of Vision. She also always strives to be a conscious connector of people who are pursuing their purpose with passion, authenticity, and gratitude. Welcome, Alyssa.
Thanks, everyone.
So, welcome to you both. We look forward to the presentation in the next hour or so of discussion. Alyssa, I'll hand it over to you and we'll get started.
Great, I'm just going to share my screen here.
Perfect.
So super excited to do this presentation today, and as many of you may or may not know, Edmonton Construction Association was my home for a number of years, so I miss you guys, very fun to be back in this capacity. And so here's what you're going to get out of the presentation today. A few high-level things, starting with an introduction to machine learning and artificial intelligence. Kind of, get through the vernacular and some of the hype and understand exactly what this alphabet soup is all about. Want to give you an overview of what the opportunity in Alberta is and why you should care. We'll illustrate some of this with tangible machine learning examples, and then leave you with some questions and a roadmap to consider so you start to understand how machine learning can be used in your organization. I like to start with this quote from Satya Nadella. He's the CEO of Microsoft. We've seen 2 years worth of digital transformation in 2 months. Now that was back in April. I think we can all agree that that feels like maybe a million years ago. But as hard as COVID has been, there are certainly some silver linings as it relates to people adopting digital transformation and technologies. We've certainly seen in the AI/ML world that people are doubling down on innovation because things are changing, and there's going to be a need to do more with less and think about the tools available to us to navigate this new world. So while COVID has been challenging, we have seen a window cracked open for people exploring new technologies, and now is a really great time to start to think about what artificial intelligence and machine learning can mean for your organization. So what this slide represents overall is the construction industry's overall adoption and spending in artificial intelligence and machine learning. The objective of this slide isn't to make everyone in the construction industry to feel bad about where they are with the AI/ML adoption. We know that generally construction industry does tend to lag a little bit behind other industries in adopting innovation and technology. But why you should care is this is an enormous opportunity for the construction industry. We have an enormous amount of talent and expertise in Alberta as it relates to artificial intelligence and machine learning. And the construction industry has the opportunity to be a leader in the field, to develop solutions and products that can serve the entire industry. Because it's totally underrepresented, there is a huge opportunity to build tools and solutions that impact our whole industry. So, you know, we're going to do a quick poll here because I just want to get to level set and kind of get an understanding of what, you know, everyone on the call's organization experience with artificial intelligence and machine learning is. So pause for a quick moment and reply to this poll. Couple more seconds here. Great, so the poll results. I know we should explore artificial intelligence, machine learning, but don't really know where to start. Candidly, that is what I expected, and I'm glad the results came out this way. You're not alone, and I would say that a lot of the industries that have started adopting machine learning are still in this space, but hopefully some of the tools from today's presentation give you a bit of a roadmap to start to have these conversations. So I want to start with some definitions, just to kind of, like I said, get some of the alphabet soup out of the way. Unfortunately, some of these things are used incorrectly or interchangeably in all of the media out there. So wanted to start with this. This is about as technical as this presentation gets. Artificial intelligence is the umbrella term for any computer that mimics all or part of human intelligence. We've all interacted with it. Self-driving cars, Amazon, Siri, all of these are under the umbrella of artificial intelligence. Machine learning is a subset of artificial intelligence, and it enables computer to adapt without being explicitly programmed. This is where you're using large data sets and examples to train the computer as opposed to giving it explicit instructions through programming. Now, a subset of machine learning is deep learning. This is really the workhorse of all of the very cool innovations you're seeing with self-driving cars, or the things that you're like, how does machine learning do that? It is really about the advances in deep learning. On a high level, it's about building multiple layers of abstraction on very, very large data sets. It's sort of mimicked off the neural networks of our brain. It's what allows computers to do some of the very, very complex tasks that attempt to replicate human intelligence. A couple more big definitions that you're going to hear as you go about this conversation is computer vision. Computers can't see the world, but what we can do is give machines a high-level understanding of video or images, so attempting to automate the tasks of human vision. If you open up your phone with your face, that's machine learning computer vision. Natural language processing, we call it NLP for short, very similar to computer vision in that it's attempting to allow computers to understand and interpret human language. If you use Google Translate, Siri, any of those types of things, you've interacted with natural language processing. So at the end of the day, what you need to understand is it's about a bit of a Russian nesting doll. Artificial intelligence, using that term for most business audiences, is going to pretty much cover the understanding of using computers to replicate human intelligence. Machine learning is a subset of that, and deep learning is a subset of that. For the majority of our presentation for today, we're going to talk about machine learning because that's where we're seeing most of the applied business solutions and applications is in that machine learning field. Okay, so this slide's very important to understand why machine learning is different than traditional programming. In traditional programming, you typically know your business rules. if then this that. And so a lot of times people get very excited about when a computer can solve a problem, and they assume it could potentially be a machine learning problem. But the truth is if you know the rules, if then this that, you can program it and you don't actually need machine learning. With machine learning, typically it's a good fit if you don't necessarily know all the business rules, or there are so many different rules it would be overly complex to build a model to train a computer. So what you do is you train it with thousands of pieces of data or examples, the outcome being a prediction. I find this much easier to illustrate via an example, so I will do that. TurboTax. TurboTax is a great example of a software program that has explicit rules. When you input your information, income, RSPs, that type of thing, goes through the program, and it gives you an output, which is your tax return. Now, it's a complex program, but it is easily programmed because you know all of the rules. Machine learning is a little bit different because it's a lot different, because it's a Wednesday after a long weekend and thought it would be fun. We're going to talk about cats. The internet loves cats. When you look at this cat, if you think about all of the different rules you would need to program for a computer to understand, this is a cat, it would be incredibly complex, and it would be completely upended when you start to apply those rules to this cat here. So instead of basically saying, I know all of the rules that I can train to help a computer identify this cat, you can actually train the computer model with thousands of pictures of cats, essentially a database that says, this is a cat, this is not a cat. It goes through the model, and at the end of the day, what you're going to get is if you put in an input of a new picture of a cat, it's going to give you a probability or likelihood, a prediction, whether that picture is a cat or not. Humans are better at some things. Identifying for humans whether this is a cat or not is quite simple. Training a computer with rules to identify if this is a cat or not is very challenging. But we can actually achieve that level of human understanding by training by examples as it relates to cats. This is not the last time you'll see cats in this presentation, so just a heads up. Why do you care? Why does this matter? This is happening now for two reasons. There is more data in this world than we even know what to do with. The sensors, IoT technology, I think we've all been on the internet, our data's out there. So the reason this artificial intelligence is happening, the huge upswing in artificial intelligence conversations happening now is because of the amount of data, but also because the cost of hardware has decreased immeasurably. So we have data, and the cost to, the computing power that is available for the cost it is, allows us to explore, some of the innovations that have been happening in this field. It is not a new field. But the reason you should care is because there is certainly an effect of starting early. The more users, the more data, the smarter your tools become, the more unstoppable, the more of a competitive moat you bring to your company and to your industry. I like to use an example with Amazon. So Amazon tells me has a tool called a recommender tool. When Alyssa buys a flashlight, it tells me I probably need to buy Amazon batteries. From a machine learning standpoint, this recommender tool is not a very complex thing to program. However, the reason Amazon is pretty much unstoppable in this space is because they have years of data and more transactions than any other organization to be able to inform these predictions. So much so that Amazon could potentially even change their business model in the future, where their prediction gets so good that they actually start sending you things before you order them. If freight costs can go down by, who knows, drones, robots, Amazon might actually completely change their business model. So I talk about this now is there is an advantage to starting early. There is an enormous competitive advantage to starting now, and very difficult to catch once you put this cycle into action. From here, I'm going to pass it off to Corey Jansen.
Thanks, Alyssa. So we're often surprised when we talk to the business community around town, in Edmonton, but across Alberta. Frankly, most executives are completely unaware of what's going on at the U of A. What we've got here on the screen right now is a timeline of some of the biggest breakthroughs in AI over the last, 20 something years, over the past few decades. You start way down at the left, actually one of the first man-machine championships ever in checkers was done with Jonathan Schaefer, former dean of science at the U of A. And you notice, over time, it took him 15 or 20 years, but he actually solved checkers. So what that means is that the AI can actually, or a human can not reliably ever beat the AI. The AI is beyond human skill in that area. You may recall this IBM's Deep Blue and this beating Gary Kasparov. This was worldwide news because, a grandmaster chess champion being taken on by a computer. What a lot of people don't realize is that Murray Campbell was actually a U of A grad, was central on that IBM team. So U of A grad, didn't do it in Alberta, but then went out as part of that IBM team. Moving into, upper middle section for those Texas or for those poker players, Michael Bowling and the team and his team, which you see pictured here, actually solved essentially every variation of Texas Hold'em. In this case, they actually got the cover of the Journal of Science after beating Heads Up Limit Texas Hold'em. A little bit of an aside, I was asking him about this and just kind of said, hey, okay, so how much have you guys made off this? And in true academic form came back and said, no, it would be unethical for us to do this. This is purely for scientific research. So they can actually beat pros across the world, but they haven't, and they haven't actually monetized it. It's all for science. And then finally, bottom left here, DeepMind and AlphaGo. This was worldwide news, this event in Asia, but barely even hit the newspapers here in North America. So the game of Go is very popular in Asia. It's material because if you look at the board, it essentially it's a very large board game, and many people thought the complexity of the game resulted in it being impossible for, there's so much gut feel that it would be impossible for a human or for a robot, for an AI or robot to ever beat a human champion. Well, this happened. So Google's DeepMind beat AlphaGo, or named AlphaGo, beat the world champion Lee Sedol. Now, China actually made this, as this came out within months afterwards, it was sort of like their Sputnik moment. Within a few months, they said, we are by 2030 going to be the world leader in AI, and we're going to put the billions of dollars there to, behind that goal to actually get there. So massive news. But again, if you notice the theme here, U of A grads, Silver and AJ Huang, were actually part of that team in London, both again U of A grads. This all related to then the first time people really heard of DeepMind in Edmonton, when after Google purchased them, they had their London office, they had the Silicon Valley, of course, and then where would you go as your natural expansion for world domination? Well, of course, you would set up next in Edmonton. So DeepMind is actually here. They're in Jasper and 101 actually this was their first research lab because of all this academic excellence. Now, we are a leader in research. I would not say that we're a leader in commercialization per se. This chart coming up is showing the U of A being a top 10 school globally in terms of this academic research over the last decade or so. Again, typically when I present this, and I can't see you all, me not being in a room, but usually I get kind of eyes start rolling going, well, who cares about research or academic papers? What does that really matter? The reason this is material is that we're producing this pipeline of data scientists. Frankly, we're producing a pipeline of some of the hardest people to find anywhere on the planet. They're coming right here to Edmonton in order to study. And frankly, we've built a business model around saying, okay, well, if we've got the most sought after job title on the planet, we should put them to work on interesting problems right here in Alberta. And for that reason, my co-founder, Nicole, and myself, we think that Edmonton is probably the best place in the world to start an AI company because it might just be the only place where there's actually a surplus of talent in terms of AI engineers and data scientists. So we're going to jump right into some examples. A few notes of these examples first. We've tried to had a selection from across a number of different industries. We do definitely have some, in construction or adjacent to construction. The point here is really to kind of demonstrate through example, really why you should care, why this matters. Because if this is all a science project that doesn't actually keep workers safer or create efficiencies or generate more revenue, then really who cares? I'll also say that most of these are the first example. I think we've got one from DeepMind here. We can go to that, Alyssa. The rest of them are going to be, they're all projects that we've worked on at Alta ML. Most of them that we can't disclose the names. You would be, know almost every one of the companies involved in it, but you can understand from a privacy concern, a lot of our partners want to keep their work relatively quiet. We're still at that phase in development for AI ML. So when DeepMind is not playing computer games, they actually set their team on a real business problem. One of them was solving some of the electricity issues or optimizing electricity usage for cooling at their data centers. As you can imagine, they use a ton of electricity across all the data centers around the world. And what you see here on the chart is when they turn the AI on and off. This actually cut down the cost of cooling 40%. What I found so interesting, and the reason we're sharing this here, is that when you read the paper around this project, it looked more like an industrial process problem than it did a technical problem. So there were a few technical factors in terms of variables or what a data scientist will have features in this model, things like number of CPU cores and other technical elements. But the majority of the features were things like set point temperatures, number of cooling towers, even things like outside wind speed. And that's not to say that outside wind speed was the most important factor in the model, but I can guarantee you, no matter how good your network engineers are, they aren't taking into account factors like this and making decisions. And so you can see when you turn over to the AI in this case, where you have a tool that helps that engineer make a better decision, it's a material impact to the bottom line. Alyssa made sure we got lots of cats in here, so here we go. I actually thought this project was a bit of, I thought my team was joking at first, but we came across this veterinarian who said that there's actually something called the feline grimace scale that a trained veterinarian, not very many veterinarians are trained in this, but could actually identify from visually inspecting a cat if there's potentially some health issues or the happiness level of that cat. And so it kind of quickly turned from a joke to a real business problem where the pet market is massive in North America, but the vast majority of visits are actually dogs, not cats, to vets. And one of the big reasons for that is that cats don't really communicate when they're sick. And so here's a case study. This is actually a real case study. As we've prototyped that, we've built out this initial model. We found that we could actually replicate what a trained vet can do with computer vision. And so as a bit of a beta test, one of our data scientists, this is his cat, was using our prototype model on this and actually determined that there was a just under 92% prediction that his cat Hobbs was unhappy, took it in, and actually did have an issue, had ear mites. So we actually are very excited. We're actually taking this and investing significant capital in this and taking this to market as an example here where it could actually really change the way the veterinary vets look at the cat market and how individuals can have more power in actually knowing when they might need to take their pet in. Our largest partner is Aimco. So we've got a joint venture with them called Alpha Layer. And so we share this use case. It goes from that sort of sexy images, kind of fun use cases with the cats to, okay, this is just a boring back office automation project. So within their real estate group, they get a ton of emails coming into this generic inbox talking about, okay, either capital calls distribution. Really, this is one of those tasks that you needed to have, say, a junior CFA or somebody be able to focus on, extracting out that information, finding those emails. Of course, there's a huge chance for human error and so forth. So what we did is we actually built a model that classified and identifies those emails that are capital calls or distributions or something else. And then we, you run this through the model using natural language processing, that NLP, to extract out the right data and then tie that into the system. Now, note that this is very sensitive financial information. The human is still in the loop. So this is a tool that automates out the grunt work from the project and then puts it through. A human still makes the call from a regulatory side and everything else from the existing business process. It works into that existing workflow. The reason I share this use case is not so, I mean, it's good. It was profitable and it continues to be profitable. It's in production. But what this did is it actually changed the discussion and the culture internally. Once the team saw that this machine learning wasn't the Hollywood scary coming from my job type technology, all of a sudden this opened the door to other conversations saying, hey, wait a minute, if you can get rid of the crappy part of the job over here, can you do that over here? Can you do that over here? And this has resulted, it's almost becoming more of a platform where many, many different business processes are now being worked into the model, where we can then take that to, say, across the organization. After you get this first one under your belt, it's that much easier to work on the next use case and the next and the next. And so it really becomes this portfolio of projects and demystifies and changes the culture within the organization. So this use case is with a large utility. It's all on using LiDAR and a bunch of other aerial imagery to predict the type of trees and the potential growth it would have in terms of right-of-ways or getting into those utility corridors. Why does this matter? Well, I mean, if you recall, down in California, the wildfires were started for just this reason. There was overgrowth that went into an area, and at least that's what most people believe was the actual start of some of the fires last year, or over the last couple of years, which resulted in the bankruptcy of one of the largest utilities in the United States. And so what you see on the screen is kind of a visualization of what we're predicting. This is still we very early stages on this one, but the initial results in terms of being able to predict are far in advance of the existing models. And because this is such a big line item within this particular utility, you can imagine just a few percentage increase in terms of what we actually take and harvest, or where we actually change our workflows as a result of this information, is easily a 7, if not 8 figure number for the bottom line. This is kind of another small one that sort of ties in more like the Aimco example. Again, it was another utility. As flyovers were done, there was a ton of, they would have to record these flights, and as they made observations, I mean, the existing business process was, it was analog, it was pretty manual. And so then by using, again, going back to this NLP, there's a theme with NLP and automating back office projects. We could automate a lot of those audio transcripts, and we free up a material number of hours from highly skilled labor, and frankly, a part of their job that they detested. I think that's key here, and this is one of the things, is that no one has actually lost their job in this use case. This is actually a productivity issue. They're not getting rid of that team. We're actually just being able to actually focus on the higher value add tasks that are needed, and there still is a business impact from that perspective. This is Alberta. I mean, there's oil and gas has been a little bit, probably similar to construction in terms of maybe a little bit further ahead in terms of the adoption. But we have done a number of projects within the oil patch. In this case, it was a company that, one of the big problems that we're seeing in various areas is because of the boom and bust that we've experienced over the last decade, especially, so many people have left the industry. So in this case, this is a pump down operator use case where a lot of those people that have been around in industry for 10, 20, 30 years they're either retiring or they're just leaving the industry altogether. And so you can imagine as you've got issues in terms of putting something down whole, every minute when you're actually performing that action costs money. But if you go too fast and you cause an issue and then you have to fish that thing out of the hole, it's a big, big issue. So our partner in this case thought of this as, how do we actually identify the highest performing operators, but then also help perform to inform, that's maybe that 20-something operator to, be able to learn and adapt like the high performing operators have done. Long-term, the vision is almost like autopilot, where, when you get in a plane and you're flying from Edmonton to Houston, well, if we ever have flights again, but when you do that, you kind of know how long it's going to take. I mean, there's a pilot still in the cockpit, that he's there, he or she is there, but that autopilot can help navigate and do that. We think that there's a lot of examples, especially within oil and gas, where you're still going to have an operator, but you're going to have that tool that helps that operator make a better decision. This is one of my favorite use cases, was up north in Fort Mac. It's a bit tough to see from this image right here. You can see those red identifiers. So this is actually from, this is a shot of a plant inside Alberta, and they had a near miss. And so we went in with one of the subs, an engineering firm, Kleinfelder was our partner on this one, that after this near miss, we said, could we take a look at the 3D models within? I don't think it was BIM, but anyway, they had some sort of internal set that of these internal 3D drawings of the plant. Said, can we use that to be able to predict where there is this insulation that might be at risk of falling? And we actually see this actually more common than anything. I'd say that next to some of our use cases in finance in terms of predicting credit defaults, safety related use cases are probably the next largest bucket of where we've worked. And so these cases are ones that we really like. I mean, it's kind of cool because computer vision, our team loves the computer vision use cases. But when this can be an input to be able to help optimize the time, but then also keep workers safer, we think the number of opportunities across construction within this broad area is frankly almost unlimited. And then last one that it was in engineering. Our initial partner was an engineering firm. Depending on your business, I know RFP for most people in the room is probably a pretty significant line item. There is so much time and money spent. We started out with the initial problem. Could we actually, better optimize the prices that we're putting in RFPs? We think that's still a long-range goal. Had a little bit of issue in terms of all the data sets to be able to predict that, but then through a variety of experimentation came down to saying, well, in this particular use case, that we could actually get pretty accurate models in terms of win prediction on RFPs. And so when you think about that, it's kind of interesting in terms of how you might use that. You could say, if let's say the sales team thinks that there's a very low probability, but then the model is that much higher, could that mean a different action or a different intervention from a team to come in and look at that particular deal? Or where there's a higher probability of winning, that maybe there's that, again, gut feel of we shouldn't go after this business, maybe we should. Or can we just fast track the whole process, right? Can we take and automate a lot of the element in creation in RFPs? Because, this won't really matter if you're, bidding on the Stantec Tower. I mean, for the big stuff, I mean, that's always going to be a situation where it's still relationships and it's the human side. But the more repeatable, the more number of, if you're talking about a lot of small RFPs where it's really tough to even know when you should actually put the time in, automating and augmenting that process, we think is a material game changer across within engineering, also construction, and frankly, professional services, and any business that sees a lot of RFPs. So this is actually a product now that we're taking to a market. We've done the initial proof of concept, worked in with our core partner, and then we've actually taken out to a number of other customers and are validating that our model is working in their scenarios. And we think that soon here, this will actually probably spin off into a different business. So I'm going to pass things back to Alyssa here, and then be around for any questions as we wrap up to this next phase.
So hopefully that gives you a good idea of, potential applications of machine learning, and you've seen some tangential connections to areas in your business. I'm just going to pause for another brief poll here. What do you perceive to be the biggest barrier to adopting AI ML at your organization? The goal here in this next last half of the next portion of the presentation is to give you a roadmap or some ideas on how to start thinking about AI ML. So understanding, potential barriers, we can speak through those and maybe answer some specific questions as it relates. I feel like I need Jeopardy music, especially since Alex is on the mend. Okay, it was pretty equally distributed, knowing where to start, executive sponsorship, corporate support, very close, access amount of data, budget, and internal expertise. So very interesting. First thing on the machine learning roadmap is to understand that machine learning projects are a team sport. I call it 3 legs of the stool, but ultimately you need 3 main ingredients to do a machine learning project: data, domain expertise, and a data science team. I see myself as being a person that goes around the world looking for big problems to solve and big data sets to help directionally solve those problems. As it relates to organizations looking at ML, they usually have the data and domain expertise, and typically the missing link is that data science team or that machine learning experience. You're going to see a lot of people, building out internal teams or looking at third-party partners that have, a bench of expertise to be able to build the solutions. But ultimately, what you have in spades is the expertise to know your problems and to have the data solve those problems. And all 3 are required to deliver business value from machine learning in your organization. This piece of advice I cannot stress enough is start with a business problem and thinking about return on investment. One of 2 things happen when people are having conversations about machine learning quite frequently. They say, I have all of this cool data. Can you please do some awesome ML with it? Like, do the fancy math and, build me a solution that is great. I would say that's like, telling a contractor, here's a wonderful build, a wonderful pile of building materials. Please build me a building. It doesn't really make sense. It's a bit backwards. So it's really important when thinking about machine learning projects inside your organization to start with the problem or the opportunity. What is the problem we're solving? And a lot of times people will say, is my company big enough to do machine learning? And that's actually sort of the incorrect way of looking at it. It's, what is the size of the problem we're trying to solve? And what would be the impact or the bottom line impact if we solve that problem? So when you're thinking about the problem you want to solve, is like the next question is there data to help solve that problem? And very, very importantly, what would be the return on investment if we solve this problem or harness this opportunity for our organization? It doesn't make a lot of sense, round numbers, spending $500,000 to solve a $750,000 problem. You want to think about the problems that are worth solving and that can have a meaningful impact on your business. This goes back to sort of that cultural buy-in and that example that Corey used with AIMCO. It's really important when you're looking at machine learning, especially for the first time, to start small and make little bets to de-risk the process. It's very, very attractive to think, I'm going to take on the biggest, meatiest problem. It's going to save me the most amount of money, and I'm going to get in the paper because it's so cool. Unfortunately, that is where machine learning projects often fail, is because there's not experience deploying machine learning within your organization. There's a process change, and most importantly, there's a huge cultural change that needs to happen for people to be comfortable with AI ML or to even understand how to operationalize it within an organization. So the key is to start small with low-hanging fruit where you can get a quick win and see a tangible result in 3 to 6 months. It's on, we're not saying don't think about the big projects, but don't start with the big projects because, in our experience of having gone through this a few times, it's much more successful to start slow and then build up to that portfolio approach and becoming an AI empowered organization. Finally, after you've kind of, I understand that machine learning is important. I understand I need to start with a business problem. I understand that I probably need to start small and thinking about it. The next step would be to really consider different projects, or in the machine learning world, we call them use cases, that might be meaningful for your organization. This is not prescriptive, but we find that looking at the different buckets where machine learning is often applied is a good way to start ideating around potential use cases. So cost reduction is a big one. We're seeing these types of use cases come up more and more, especially as people are doing more with less in this COVID environment. So certain things like reducing project management costs, inventory optimization, predictive maintenance, we see this one a lot with machine learning. So, if you're working capital heavy, or if you have, a lot of equipment, preventative maintenance use cases are really interesting. Risk reduction, Corey mentioned that safety is a big place for computer vision and machine learning. So it could be safety on a job site, safety on safety in a plant, but, staying in compliance with government regulations or within a project budget are areas where machine learning can give you insights or help augment decision-making. And that's a type of risk as well. And this last one, as it goes back to that competitive advantage we were talking about before, is it machine learning insights and solutions in your organization can help, give you insights that will help you when you're entering new markets via an improved value proposition. The RFP example is a great one of that. Or, improving the effectiveness of your sales force. The operating, helping your team operate better or understand the gaps in their training is also a big one we're seeing in this area. So as you think about, where do I start? That was something that came out with the poll. Think about these buckets, the size of the problem, and the return on investment. This is a tool you can take away. It's one methodology to start to put all the puzzle pieces in place, to start to see what is the feasibility of this use case or this problem I have in mind. It's starting with the problem. What's the problem I want to resolve? And back to that programming language, what is the prediction? If I can predict this, how will it help me solve the problem or help impact a decision? A big one is understanding also the business task. How will this change my processes? How will this change my workflows? And why is that meaningful? A big one here is also the data sources. Starting to think about where your data is housed, how it's captured, how it can be exported is a big part of the machine learning process. So the more time you can spend sort of conceptualizing where your data is and how you might use it, the better, and especially as it relates to specific problems. This canvas can definitely be a tool for that. And finally, and I can't stress this piece enough, is understanding and trying to quantify an estimation to the best of your ability around the return on investment and strategic impact as it relates to the problem. This will help you, because I imagine once you get going and excited and get people ideating around certain things happening in your organization, you will have a glut of potential use cases. Some of them you might determine are, maybe they're traditional programming problems, but there will be a necessity to prioritize which ones you take on first. And that quick win is a good way to think about which ones to take on first, but also what is the potential return on investment and strategic impact that exploring this use case could bring to our organization. So you don't have to do it this way. It's just one tool that you could potentially use internally to start thinking about different use cases that will support your organization. And finally, I'm not going to read all of these out. My point being is that there are so many potential opportunities down the entire value chain of the construction industry. And really it comes down to industry saying, here are the problems we want to solve. Here are the data sets, and then working with the huge talent pool we have in Edmonton and Alberta to solve the problems with machine learning. I'm really very optimistic and excited about the horizontal enabling capability that machine learning can give to all of our industries that we have in Alberta. And I know we're a leader in construction. So, like I said at the top, this is very, I'm passionate about this industry. I think there's a lot of potential, and it's, thinking about having organizations thinking about, what are the things we can do together to amplify the entire industry, and starting with our own organization. So I'll stop there. Corey for closing comments, and then I think we'll do a little bit of Q&A in the last 10 minutes here.
Perfect. Yeah, and I think we'll probably just jump right into Q&A. But I'm almost a bit ashamed to say, being in tech in Edmonton for 20 years, it wasn't until 4 or 5 years ago that I even realized we had this amazing group coming out of the U of A. And I just can't emphasize the point enough that a data scientist without data has nothing to do. And even with that data, unless you combine them with the subject matter expertise, what we've seen from doing 100 plus different models, you don't get success. You really need to actually have all those groups at the table. And so starting that discussion and even being able to identify where there might potentially be a use case. As you can see through this presentation, it's not that technical. I mean, we didn't go into the nuances of neural networks and all this gobbledygook that you see coming out of our good friends at academia, who we respect immensely, but that doesn't get to the bottom line. So if at least, really the goal here was to just maybe hopefully spark a little bit of inspiration, say, hey, if it could be potentially used in this area, then what might be that next step? Or because the data scientist, he or she cannot do it without the business side being at the table saying, I've been thinking, could we optimize this? So Matt, we'll turn back to you here.
Yeah, no, thank you both. Thanks, Alyssa and Corey. Really enjoyed the presentation. Some really neat takeaways, especially around some of the RFP stuff, particularly. I know I've heard a lot of companies, especially during this market, who are having to submit a lot of RFPs. There's opportunities, but you can get blinded by all the opportunities, and having a tool to perhaps be able to help sort through that would be immensely helpful. We do have a question, and before I ask that question, I'll just say to the attendees, participants, if you have any questions that you'd like to type in as I'm asking this, please do so, and we'll be sure to get to them. This question is from Amir. It says, good morning. An important factor for effectiveness and high predictability of AI and ML comes from having big data. Most of the small and medium-sized enterprises are facing the same challenges, but don't have a large amount of data, like unsuccessful bid, scale of transaction scopes. What is your opinion about application of ML for SMEs?
So this is an excellent question. He hit on a bunch of points there. So Amir, what you've alluded to in the question of well, it requires big data. In many cases, yes, it does, but it's not always big data. So when we're talking about deep learning, that's almost always big data. But some of the classical or more shallow models aren't not necessarily, and the definite, we could get into a rabbit hole, because I could sit here with my VP data science and talk about what is actually big versus what is not, right? I think there's often different perceptions from, the terabytes and terabytes of streaming data that comes in from some instances, especially in finance or autonomous driving versus other areas. So you're correct though in your suggestion that you need a bunch of data, and big companies have it. And larger organizations, I'm not going to sugarcoat it, they do have an advantage. But they also have a major disadvantage. It's really tough to do innovation the larger the organization. And that's not just a construction thing, that's just any industry. And I mean, we've got 30 enterprise clients, 30 plus enterprise clients. And so we've seen this across the board. Because within each enterprise, it's not necessarily that they have access to data. There's these silos often across big companies. So in theory, you have access to the data, but it's not always easy to get there. So yeah, bigger is better, but you don't always need the data. But we like to phrase this, and Alyssa talked about it a little bit or alluded to it. It's the magnitude of the problem, not the magnitude of the company. We've done projects with let's call it a dozen or so mid-market or small to mid-market, so sub $100 million companies, where there actually has been a large enough project to actually justify going in and doing some experimentation. You know, if it's a problem that costs you $100,000 a year, and it's going to cost you, 50 to 100 grand to do a solution, it's not even worth it, because there's a technical risk there. You want some margin of safety. We've seen a large number of use cases that our Goldilocks scenario is, hey, we think we can build something for $250,000 to $500,000, and we think it could save a few million bucks. When you've got that margin of safety, even if we're completely wrong, we know we're going to have a happy partner in the end. And so we're always striving for that, but it's not necessarily so clear cut. Here's one idea that I think is a tangible one for the industry and what we've seen happen in a bunch of other areas. And that's around the subject of a data trust. We're seeing this actually happen at the federal level, where there's an acknowledgement now with what we see in terms of how Facebook and Google and the consumer space, how our data is, how much value there is in our data, and how frankly so much of it is sucked south of the border. Where there's those right situations where an industry can agree on subjects, is there the ability to team up together and pool some of that data where maybe independently we don't have enough, but in aggregate we do. So we're never going to make that happen on the RFP one. Sorry, Matt, like I just know none of you are going to give up. And the first question you'll have is make sure none of my competitors can see my data. And we have to ensure that in any one of the projects we work on. But take an area with maybe a larger social good like safety. I could see, there's certainly, I could see everybody around the ECA come together and say, hey, you know what, we actually think we want to solve these problems. Who's got this form of the data? And in aggregate, if you have anonymized aggregate data, maybe we can actually take this on. We're doing the exact same thing in health. We're trying to push the exact same thing in oil and gas. And so it really depends if there is the leadership within an industry. There are models there that can allow the small guys to compete with the enterprise level clients. So let me pause there, but you've hit on so many correct, elements of your question. That's a long answer, but it's a great question.
And I'll add just one more thing, is that I have not spoken to a single client that doesn't have a degree of insecurity as it relates to their data. Like, I don't have enough, it's not big enough, and so it's like the degrees of bad, I get it. So degrees of bad when looking at data. And so one of the things that's very like a ancillary benefit of looking at this is when we pop the hood and start to actually analyze the data you do have. Yes, sometimes it's enough to start, one of those shallower machine learning models, and then give you the feedback to let you know what type of investment into the data infrastructure you need to make. So I think it's a big mistake to say, I need to wait till I have more data or my data is perfect to start to explore, because that's sort of a unicorn. It doesn't really exist.
Good, thanks. We've got a few minutes left. I don't have any other questions popping up, but I did have a quick question to ask, and it gets back to the where to start. So, what's one thing a company can do to start tomorrow? If they're ready to go, how do they start integrating this into their organization?
So I'll give you one. I mean, obviously we're happy to have a conversation, but if you've got a desire to, education is such a big piece of this, and understanding some of the term, like, again, I think we've shown here, once you get beyond it, like you can get through all the BS with the alphabet soup that's out there and the marketing buzz, right? There's a really famous data scientist, his name is Andrew Ng. His last name is NG. He was a Stanford prof that put his course out for free. He also put up a course on Coursera, free video course. It's called AI for Everyone, that if you want to go into a little bit deeper, it gets into, some of these concepts we talked about here into a little bit more detail. If you had the right champion within an organization, you understand those right cases. I would say that just having that piece of it and understanding and getting through to teams that this is not some, marketing tech buzzword that's out there. All machine learning is the optimization of business processes or the reinvention of business processes using this new tech. And so once you start talking about, okay, I get that, like, how can we optimize our workflows? How can we do things better? I mean, there's actually no industry that does that better than construction. It's just that the data often isn't digitized. So when you frame it in that mindset and you realize it's about making predictions, optimizing these business processes, all of a sudden you go, okay, like just whatever you do, don't just put this and hire a data scientist and put him or her in IT. It won't work, right? So if you do have the buy-in, if it is a strategic fit, the education piece, and then starting to have conversations that obviously there's organizations like us, but I'd also point out to Amy. Amy's a group that this Alberta Machine Intelligence Institute. If you want to start building an internal team, their whole mandate is to actually have those conversations, say, how do I identify, how do I hire, how do I go down this path? And so we'd be happy to make any other introductions if one was so inclined to actually try to take this on internally as that first step.
Excellent. Well, a big thank you again to both of you for presenting. Amir is just putting in another question here. Amir, we'll see if we can get that answered offline for you. We're just closing down here, but it sounds like you know, obviously Edmonton's well positioned, and the industry, the construction industry, can be well positioned to take advantage of the services that you offer, and just the immense amount of creative energy and horsepower that we have in our region. So thanks for exploring that with us. Just a couple quick notes before we close out here. Just a reminder that we've recorded this session and it will be available. So we'll post it up on YouTube and Facebook here in the coming days. We can also make the presentation available. So it'll be part of the recording, obviously, but if you'd like the presentation, just to go through after, Alyssa and Corey will make that available. We'll have it, so we're happy to distribute it to all of you. A couple quick notes with regards to ECA stuff and courses. I wanted to talk a bit about our digital project delivery course, which, you know, sort of has a bit of a digital tie-in to it. We are offering this course September 23rd and 24th, and it brings together leaders from the OEC to learn together about the best ways to deliver efficient and cost-effective products using collaborative technology. So if you're interested in that, please take a look at our website. And the second is our Emerging Leaders Institute. This event is in early October and is focused on field leaders or managers in their first or second leadership role. It's presented in partnership with FMI, and it's an immersive 4 half-day virtual course teaching those who are participating on communications, delegation, and team building skills, as well as team management, client management, and problem solving. So again, information with that can be seen through some of our newsletters. We have it on our LinkedIn pages, and it's of course on our website. So with that, I want to thank you again for taking the time to join us today, and I wish you all the best today.
Thank you, everyone.